When users misspell queries, weak search feels broken immediately. I will build typo-tolerant search with facets and ranking rules in Meilisearch using Python. This is the setup you'll be able to run after this, which indexes records with synonyms and runs a typo-tolerant search filtered by a genre facet. I'm Professor Pi, teaching search and IR with simple Python. Search breaks when people mistype product names or book titles. That failure is obvious and costly. Meilisearch gives an approachable way to tolerate those typos while keeping results relevant and fast. For Python folks, it feels like adding a friendly layer that corrects small mistakes and still listens to user filters. At its heart, typo-tolerant search accepts small edits in queries and still finds the intended documents. Success looks like a one-character misspelling, returning the same top result as a perfect query. We also want facets, so users refine by things like genre or year. And simple ranking, so newer items can surface when appropriate. Meilisearch is a good fit because it ships typo-tolerance, synonyms, filters, and sorting as an integrated service, so you do not build fuzzy indexing from scratch. We will build a tiny index of books, demonstrate a typo query, add a synonym, enable a genre facet, and then sort by year to show recency ranking. The code is straightforward and stays close to basic Python, so it feels more like plumbing than deep IR math. Now we'll create a tiny index and run a first search. This snippet connects to a local Meilisearch server, creates a fresh index, loads two small documents, and runs a first query. The Meilisearch.client object opens the connection, and the variable IDX references the book's index for later calls. The function client.createIndex schedules index creation, and client waitForTask blocks until the task finishes to ensure subsequent operations are valid. The list docs holds a tiny, readable dataset, and IDX.addDocuments adds it to Meilisearch. After another waitForTask, IDX.search performs a keyword search for Hobbit over the default searchable attributes. The printed title confirms the pipeline works end-to-end and that a matching result is retrievable. Next, we will try a misspelled query to see how Meilisearch tolerates typos. This example runs a misspelled query to show Meilisearch's built-in typo tolerance using the same IDX.search call. The variable 2 holds the query Hobbit, which differs by one character from Hobbit, a classic single edit case. The function IDXSearch returns a response with a hits list. The code selects the first hit's title, or falls back to none if no matches exist. Because Meilisearch tolerates small edit distances by default, the intended document still appears. If the query words were longer, Meilisearch could allow 2 edits. Shorter words typically allow only 1. The printed title verifies that users still get a relevant result despite the typo. Now we will broaden the search by adding a synonym, so different words map to the same concept. This code adds a synonym mapping in Meilisearch, so searches for halfling also match Hobbit content via IDX.update settings. The variable syn defines a small, symmetric dictionary which the API stores on the index to expand queries at search time. The call client.waitForTask ensures the settings update is applied before we test. Next, IDXSearch runs the query halfling, and the engine rewrites it using the synonym set, allowing our Hobbit documents to match. If you add more domain terms to syn, recall increases, often at the cost of slightly broader result sets. The printed title confirms the synonym successfully broadened the query's reach. Next, we will enable faceting and apply a genre filter while keeping typo tolerance active. This snippet enables faceting by marking genre and year as filterable in Meilisearch with idx.update settings. The call client.waitForTask blocks until the setting is active, ensuring the next search can use filters. The function idx.search then executes a typo-tolerant query Hobbit while applying a facet filter that keeps only fantasy documents. Filters act after matching and ranking, reducing noise without changing the core typo-tolerance behavior. Tighter filters increase precision, but can hide relevant items if the filter is too narrow. So choose attributes that users naturally refine by. The printed count shows how the filter trims results to the intended category. Now, we will add a more recent document and run a recency-first search so newer matches float to the top. This example inserts a newer related document, enables sorting on year, and runs a recency-first search in Meilisearch. The list D introduces Hobbits Abroad with a 2005 timestamp, and IDX Add Documents loads it into the index. After waiting for ingestion, idx.update settings marks year as sortable, so the engine can order results efficiently. The subsequent IDX search applies a sort parameter year_desk, which reorders matches to prefer the most recent items. Switching to year ASC would instead float older classics for archival or historical browsing. The printed top result shows the newer title rising above older matches, confirming recency-aware ranking is active. In a real project, this same pattern maps to product catalogs or help centers where users mistype brand names or use synonyms. The small corpus here becomes a larger index with many documents, and the same filters and sorting choices scale the user experience. Recap: Meilisearch typo tolerance accepts small edits so users still find what they mean. Use synonyms and facets to increase recall and let users refine results. Watch filters closely because they raise precision but can hide matches. Next step, scale the same setup to a larger catalog and measure latency and recall while tuning typo thresholds and synonym coverage. That will show trade-offs and guide production settings. If short, practical IR helps, subscribe and watch the IR videos.